This is a demonstration of labs 4.1 through 4.3, separating solutes. In our last lab, we looked at one technique for separating a mixture back into its pure substances. However, that filtration technique did not work for perfect solutions in which the solute was fully dissolved in the water. Today we're going to look at how paper chromatography can be used to separate inks and other dyes from water. This experiment may be one that you're actually able to complete in your own home. It only needs a few simple materials. First, I have a beaker filled just at the very bottom, about 2 centimeters high, with water. You can use any cup for this experiment. Second, I'll be using some strips of something called chromatography paper that I've cut just small enough to fit into my cup. While you may not have chromatography paper at home, coffee filters work really well for this. Lastly, I have some markers and pens in a few different colors. Now, it doesn't really matter that we're using markers and pens. What this is something that has a lot of color to it, similar to our copper 2 sulfate solution. This is a solution that has a lot of ink and dye in it, so we'll be able to see it separating easily. The last thing I have is a pencil. You can use really any kind of stick. This is just to hold materials over the top of our cup. I'm first going to start with my green marker. Now, remember, the goal of this is to separate mixtures. So we're going to treat this marker like a mixture of two things, green dye and water, because it's a wet tipped marker. I first took my chromatography paper and I saw how high up the water might come in it. I then placed a big green dot on my paper just above where the water would be. Finally, at the top of the cup, I folded my paper over because I'm actually going to hang this into the water. Now, it took me a few tries to get this right, but you can see I have my pencil just sitting over the top of the cup with the water hanging off of it. And as we know water does, it is already starting to creep up the paper. Pause the video here and write down your predictions. What do you think the water will do to the ink dot once it reaches it? Okay, at this point, it's been about 5 minutes and we can see that something really interesting has happened. I'm gonna pull it out. As the water interacted with our ink dot, you can see that some of the ink was actually pulled up with it. But in that, we also see some separation. Towards the bottom, I see more of the green colors, and towards the top, it looks almost bluish. It turns out that within the green dye, there are actually multiple compounds or multiple pure substances that made up that green color that we've been able to separate through our paper chromatography. In fact, most ink colors are a combination or a solution of several different dyes. Just next to this beaker, I've done the same thing with dots of green, red, brown, and black. Let's take a look at what that looks like. So on the left, we see the same thing with our green dot, where it separated green and blue colors. In order from left to right, after the green, we have a red marker, a brown marker, and a black marker. What are some of the different solutes that were dissolved to make those colors? One way that this chromatography separation method is commonly used is in investigating things that on the surface look very similar. Here, I have 3 black dots that are made with some very different pens and markers. Sometimes companies, especially legal companies, will use a very special ink to print or write their things with so that they can always know what came from their office. Pause the video here and make some predictions about how you think these might react differently in paper chromatography. These are the same 3 dots about 5 minutes later, and I see some really interesting differences right off the bat. The one on the left appears to still be mostly black, but it has bled and moved quite a bit. Maybe there's a little bit of red around the edges. Do you guys see that, or am I making it up? The marker dot in the middle, however, looks like it had some blue solute mixed in with its ink. And then finally, this dot here on the right hasn't moved hardly at all, but I do see a little strip of what looks to be like a yellow solute that has bled from this. As you stop the video here, answer any questions that remain on the slide. But I want you to think very specifically about how this could be really applicable in real life. What is one way that being able to tell the difference between some identical looking markers or pens could be useful to somebody investigating something?